1 differentiation, example 4. This time we are applying differentiation to help us to find the x-coordinates of the points on this curve where the gradient is 2. So we have a curve and we are finding the gradient. That's a clue to use differentiation. Now, the curve is currently fully factorized, which means it's not ready to differentiate. It must be in the form kx to the power n in order for us to differentiate it. So let's get it ready. 3 pairs of brackets. So what I'm going to do is expand 2 of them to begin with. So I'm going to expand the first 2. It gives me x squared. And then plus 1x minus 2x, which is minus x. And positive 1 times negative 2, which is negative 2. So I've expanded the first 2 brackets. I still need the brackets that I've written in here. If I didn't write them down, it would be wrong. So I'm down to 2 brackets now, where I used to have 3, but the same rules apply. Everything in the first bracket needs to be multiplied by everything in the second bracket. And since there are 3 objects in the first bracket and 2 in the second, there's going to be 6 terms here before I collect like terms. So first of all, x squared times x cubed. Then I'm going to do x squared times positive 3. So that's positive 3x squared. So I times both x and plus 3 by x squared. Now I'm going to times both x and plus 3 by minus x. So x times minus x squared, plus 3 times minus x, minus 3x. And finally, I've got both terms in the last bracket now to multiply by minus 2. So we've got minus 2x and minus 6. So 1, 2, 3, 4, 5, 6 terms. Some of them can be collected together. So we've got 1x cubed. But when I collect the x squareds together, I've got 2x squared. Collect the x's, I have minus 5x. And there's only one constant term. So that still equals y. I'm now ready to differentiate. So differentiate the left-hand side, and I get dy by dx. Differentiate the right-hand side, I get 3x squared plus 4x, take away 5. Remember, differentiating a constant term gives you 0. So now I'm going to find the points, or rather the x-coordinates, of the points on the curve where the gradient is 2. So now I need to solve where does dy by dx equal 2. So 3x squared plus 4x minus 5 equaling 2. This is clearly a quadratic equation, so we must make it equal 0. And then factorize if it will factorize. If it doesn't, we could use the quadratic formula. This one does factorize. Get 3x and a 1x in each bracket. I put a 7 there and a 1 there. And if I put a plus in front of the 7 and a minus there, I know that's correct because I'm imagining expanding this. It gives me 3x squared, which is what I want. And then the middle term gives me 7x. The outside terms give me minus 3x. Collect those, and I've got plus 4x. And then positive 7 times negative 1, negative 7. So I know it's right because it works. Expanding it gives me what it had before. So this tells me that to make this equal to 0, x would either be minus 7/3 or x would equal 1. Now the question didn't ask for full coordinates, it just asked for x-coordinates, the points where the gradient is 2, and we found those points. Now I'm going to sketch the curve. And actually, what we've just worked out doesn't help us that much in sketching the curve. The most useful thing here for sketching the curve is the original fully factorized form. So here's what we need to consider. First of all, what type of graph is it? Well, it's cubic. We knew that hopefully before we expanded it, but expanding it confirmed, yep, it's a positive cubic. And positive cubics have this general shape. That's very rough. I'm going to rub that out. But that's the general shape of a positive cubic, and you must know that. The factorized form tells me all the points where this curve crosses the x-axis, because on the x-axis, y is 0. So this will equal 0 when x is minus 1, and when x is 2, and when x is minus 3. Those are the three places where it will cross the x-axis. Remember, it's a positive cubic, so that's going to be the general shape, like that. Let's sketch. So there we go. That's the curve. Now, the question didn't say show where it crosses the axes, but let's do that just for practice. So at this point here, we know x is definitely 0. And that's the x-axis, that's the y. X is definitely 0 here. So let's sub that into either the original form or the expanded form. Doesn't make any difference. I'm going to sub it into this one here. So if x is 0, y will equal nothing plus nothing, take away 6. So this y quadrant here is minus 6. And that's the end of example 4.